Hi everyone, this is Nitya Jaikumar, Professor in the Department of Information Technology at K.S.Rangasamy College of Technology. The topic for discussion is Microprocessor 8086. So we know a microprocessor, which is a programmable electronic chip, which has computing and decision-making capabilities. So any decision-making capabilities or any automation process is done only by means of microprocessor. We can say microprocessor is the heart of any computer system. Nowadays, we are be seeing microprocessor in our all walks of life. So your day starts and your ends with a microprocessor. Okay, I'm sure with this term. That is all your electronic devices like your mobile phone, your printers, washing machine, fax machine, microwave ovens, all will have a processor. So anything to be optimized, there comes the role of a processor. So it also not only for our day-to-day life usage, it's also used in advanced applications like a radar, satellite, and flight. So a microprocessor, like a CPU, it's a heart of a central processing unit. It will be associated, it will work only with the help of a memory unit, where will you store your data or your programs, whatever may be, it's a storage unit, and it will be associated with your input and output units. So you store your programs, you read the data from that memory. The processor will read it from your memory and it will be having associated with your input and output devices. So we have three types of communication lines associated with all your processor working. So we have data bus. The group of connection lines are called as a bus. So we have data bus, we have control bus and address bus. So control bus is one which is bidirectional. It is associated with all the units. It's also associated with the processor, memory, input, and as well as output. In case of address, the processor initiate the address. The address from the processor, it will be going to a memory or out of the different input device, which device you are accessing, that will be denoted, or an output device. So this address bus is used for accessing either a memory location or an input or output device. So it is a unidirectional because it is coming from the processor to one of these devices. And if you say a data bus, it is bidirectional. That is, from the memory, you can write a data into the memory or read a data. So bidirectional. From the input device, you read a data. For an output device, you write a data. So it is a bidirectional way of a communication associated with your data bus. So coming to the 8086 microprocessor, which is a basic 16-bit processor, we'll be seeing now. So Intel released its first 16-bit processor 8086 in the year 1978 due to the demand for the high powerful and high speed computers. And this has a powerful instruction set and more programming flexibility. It is a 16-bit processor. So when you say a processor is of particular bit, it means that it can perform that much number of bit operations at a time. So for example, here this 8086 is 16-bit processor. It means it can perform 16-bit operations at a time. That is, it can read a 16-bit data, write a 16-bit data, process a 16-bit data at a time. So the width of the data bus is 16 bits. 8086 has 20-bit address bus. That means it can access up to 2 power 20 locations, which will round off to 1 megabyte. So 8086 processor is capable of accessing 1 megabyte of memory. So it has multiplexed address and data bus. That is the same type of communication lines, that is pins which are available in a processor, is used for both address and data. So totally 20 lines is needed for address and 16 for data. If you allocate separate lines, it will not be sufficient because 16 is needed for data, 20 for address. So what we do is, we'll not be using both address and data at the same time. Once you place an address, then only you will be accessing it for data. So the first 16 lines, it will be used for both address and data, that is AD0 to AD15, which means address and data. The remaining 4 lines, that is A16 to A19, is allocated specifically for address. So that's why it has a multiplexed address and data bus. So coming to the other features, it can support up to 64,000 input-output ports. You will have registers available in your processor. This is the way in which you use it for programming, assembly language programming. You have 14 number of 16-bit registers. Just a 5-volt supply is enough for making a processor to work. A 40-pin IC, it is a the special feature of 8086 is the pipelining architecture. We will see in the coming slides, where it can fetch up to 60 instruction bytes from the memory and it will do the instruction execution. Initially, the clock frequency, it is of 5 megahertz. The later versions will have 8 and 10 respectively. So To start with the architecture, first we know what are the registers available. I told already that it has 14 registers. Out of the 14 registers, general purpose registers are 4 in number. These are the names given for the general purpose: AX, BX, CX and DX. And segment registers are another 4 in number. Pointer and index registers 4, totally 12. And the next is instruction pointer, which is the 13th count. And the last one is a flag register. We'll see one by one. So general purpose register, these are the general purpose register, which is accumulator, base register, count and data register. Where accumulator is used for doing IO operation, that is input operation, output operation, and also in string manipulation. Where a base register will hold the offset address while you're calculating a memory location, that is to calculate a 20-bit memory address. And a count register, that is whenever you are performing loop instructions, a particular group of instruction to be repeated, how many times that the instructions has to be repeated, that count value has to be loaded in this count register. Where data register DX is used for holding a device address, that is whether which input device or which output device, that input output device address will be stored in DX register. So each register has a particular defined function to be performed. So coming to the segment registers, we have 20-bit address. So the memory allocated for this 8086 processor is 1 megabyte. So out of the 1 megabyte of memory, we cannot access as such. Like what we do in our computers, we divide the memory into drive, C drive, D drive, E drive. Likewise, this entire memory is divided into different segments, which are called code segment, stack, data, and extra. That means code segment is the memory area which is used for storing only the programs. Stack is the one which is used for storing only the stack data, that is temporary storage information. Data is used for storing a data, and an extra segment is used for storing a extra information, additional information. Then coming to the pointer index register, it is mainly used for holding the offset address while you are calculating for a 20-bit memory address. Stack pointer points to the stack segment. Base pointer holds the offset address related with your stack segment. And the source index is used for string operation, source data, and destination index is used for holding a destination data. Likewise, each has a unique function. Then the last two are instruction pointer and flag register. Instruction pointer, which is 16-bit register, it's just acts like a program counter. That is, you write a program for a specified function to be performed. A program, you have a starting address of a program that will be initially loaded into the instruction pointer. Once you start executing the instructions line by line, automatically the counter will be, that is the instruction pointer will be incremented and points to the next instruction to be executed. So then and there, whichever instruction to be executed, it will be pointed by the instruction pointer. The last one is flag register, which is also a 16-bit register. It is also called program status word. We can say flag register 1, which reflects the status or what actually your status of your processor is. So we have a 16-bit. Out of 16 bits, we'll be just using 9. And out of 9, 6 are status and 3 are control. Status is the one which reflects the status of your processor. Control is the one where the user can control a function of your processor. That is the difference between these two. Where status flag is there carry, parity, auxiliary carry, zero, sign and overflow. And these are all the indication of the result of your any after performing any arithmetic operation, arithmetic or logic. So if you perform any arithmetic operation, if you at the result, if you get a carry, this flag will be set. And if a parity is observed, this flag will be used. And if you have a carry from one nibble, that is a part of a byte, one nibble to the next nibble, this auxiliary carry will be indicated. If the result of any operation, the result will all zeros, this flag will be set. This is for signed operation. If the result exceeds the limit, overflow. So the entire status will be indicated by these 6 flags. And the next 3 are for control. That is interrupt flag, whether we can allow an interrupt or not. In which direction a string operation has to move, whether increment or decrement. Whether you can allow a single step execution of your program, like compiler or interpreter. Whether you are compiling a program as a whole or you do single step execution. All will be denoted by means of this control flag. So this is a way in which your flags are denoted. So out of 16 bits from 0 to 15, this is carry, parity, auxiliary carry, zero, sign, trap, interrupt, direction, overflow. This is the order in which your flags are configured. the last. This is the architecture which shows uh, the entire working of your 8086 processor. So as we have seen in the earlier slides, we have 14 registers. This is the way in which 14 registers are accommodated, configured. So we have AX, BX, CX, DX. These are all general purpose register, pointer register, stack pointer, base pointer, source index, destination index. And then we have 4 segment registers, code, extra, stack, data, instruction pointer. Some internal registers are available. And then temporary register for temporary storage, ALU for arithmetic logic execution. The result of any execution will be reflected in a flag register, and we have an instruction queue available. This is used for your pipelining process. Okay. Now, this entire architecture of your 8086 processor has two units. One is called bus interface unit and other one is called execution unit. So you have a program available for a particular processor to execute. The program will be stored in a memory. First one, a memory has to be, that is, a address has to be generated to access the program from the memory. That address is pointed by instruction pointer, which points to a program. So that instruction pointer, if any offset is there, that will be added. Address will be generated through the address bus, and then it will be given to the memory. Through the external bus, the address will be given to the memory. Fetch the data from the memory. It is a bidirectional. Then it will be fed up in the queue. So this is a queue which can store maximum of 6 bytes. So whatever your program that will be in the form of an opcode, that program will be forwarded to the queue. So the bus interface unit role is to just fetch an instruction opcode and then pass it on to the queue. It will keep on doing that process. It doesn't bother whether the instruction is getting executed or not. Okay. Then once the instruction queue is getting filled, it is a role of the execution unit to execute the process. That is, it will be a first in first out. So whichever instruction is fetched first, that will be read up by the execution control unit. Fetch the first instruction, decoded, what function it has to perform, that will be decoded. Correspondingly, fetch the data. Suppose if we are fetching a data from AX register and load in some location, fetch the data from the register. Through the database, it will be loaded and then pass through the memory. Otherwise, if you are going to perform any arithmetic operations like add AX and BX, fetch the data from AX, fetch the data from BX through this database, store it in a temp register, add using your arithmetic logic unit. Based on your addition, the result, the flag register content will be affected, and the result may be stored in final answer, may be in AX. So all this function will be performed. By the time you have read the first instruction, the queue is of size of 6 bytes. You have fetched the first instruction, the queue will be empty here. So you can fetch the other instruction, next instruction, and feed it into the queue. So likewise, we have a parallel execution of this process. That is, this is the first process which has started execution of pipelining concept, that is parallel execution. This unit will keep on fetching a data from the memory, that is code from the memory, and fed in the queue. The role of the execution unit is to fetch the data from the queue, decode it, and start executing it. Both will function in a parallel way. So that's why a process will happen in a faster rate. So speed will be increased. That is the main advantage of 8086 microprocessor. So we have seen the architecture of microprocessor in detail, what are the registers available, and using the registers, how a processor will do a function. So a role of a microprocessor is very much predominant in our day-to-day life. All your embedded systems will have a process. All your automation work will have a processor. So in this way, the role of processor is very important. Hope you have got an idea about how an 8086 processor is configured and what are the registers are available in it. Thanks for watching the video. Happy learning. Enjoy the process. Thank you.